Welcome to the feedback from C4.1.2, the Halogens quiz. So as we can see, only 2 of you have responded to this, which means the feedback isn't particularly great, but I'm going to do it anyway. Right, so question 1 was, which is the most reactive of these halogens? And both of you managed to get this correct. Fluorine is the most reactive of the halogens. So remember, the halogens are group 7, and they get less reactive as you go down the group, unlike the alkali metals, which show the opposite trend. So this links with question 2. So what's the correct explanation for the trend in reactivity down group 7? And both of you managed to get this right. That as you go down the group, so the atom gets bigger, as it does in all groups. So in the alkali metals, they were trying to lose an electron, so they became more reactive as you went down the group. So the group 7 elements, because they're non-metals, they're trying to gain an electron. And if that electron's further away, then it's more difficult to gain it because the attraction between the positive nucleus that's trying to gain the electron and the negative electron is weaker, so it's more difficult to do it. So they're more reactive at the top of the group and less reactive at the bottom. Right, question 3, which of the following correctly shows the states of matter for group 7? So this isn't an understanding, this is just learning facts, and happily both of you managed to do this. So the correct answer is that fluorine and chlorine are gases, bromines are liquid, and iodines are solid. Question 4, what type of bonding is present in the halogen elements? Only one of you managed to get this correct. So the correct answer is simple covalent. So because they're non-metals, bonding with other non-metals, it's got to be covalent. And then between simple and giant, that's just a question of learning which groups do which, and all of group 7 do simple covalent because they're small molecules. Remember, they're diatomic, so they're just F2, Cl2, Br2. One of you has answered ionic. You can only have ionic bonding if you've got a compound, so no elements can do ionic bonding because it has to be a metal losing an electron and a non-metal gaining an electron. So question 5, which of these describes and explains the trend in melting point as you go down group 7? So again, one of you got it right, one of you got it wrong. So the trend in melting point as you go down, as we've just done a question on the state. So chlorine and fluorine are gases, bromines are liquid, iodines are solids. So the melting point's clearly increasing down the group. So that means it's got to be one of the last 2. And the options, you can't see them there. The first option is that it increases due to stronger intermolecular forces. And the second option for increases is due to stronger covalent bonds. So to answer this, you've got to think about what's happening when it melts. And when it melts, it's the forces between the molecules that are being overcome. So they're still, when they've evaporated, when they've gone from a solid to a liquid, so they've melted, or when they're going from a liquid to a gas and they're evaporating, the molecules are still remaining intact. So the covalent bond between the 2 atoms is staying intact. So it doesn't matter how strong the covalent bond is. That's got nothing to do with the melting point. It's only the forces between the molecules that are being overcome. Okay, thank you for listening. See you on the next video.